every one of us, please look at this page 17. Okay, what are we going to do today? After we have finished, what? Ion test, and after we have finished the preparation of salt, means can end earlier. No. Today, we are going to do the very last part, which is the heating of salt. Okay, the heating of salt and also some questions. We will try to do 6 questions today. So, page 17. For the color part I skip because I assume you all are very good with the color already because you all got nothing to do at home, and then I believe you all will flip the book and then you study a little bit. The moment when you study a little bit of color, then you will be very tired already, then you stop. You never study heating of salt, never mind. You do the color of salt yourself, and then I do the heating of salt for you today. Okay, for heating of salt, heating is also known as a decomposition reaction. If you do know, please write it down. Heating also means decomposition. And then in the SPM, they only come out these 2 types of example. It's either they heat carbonate salt or they heat nitrate salt. They don't heat other salt. Because if they heat other salt, you cannot do. You do know how to do. SPM, they're very kind one, okay? Most of the time. So first, if they heat a carbonate salt, what is a carbonate salt? Carbonate salt means they have CO3 in the salt. What are the products that is going to produce? Remember, as long as it is heating, as long as it is decomposition, salt will decompose, break up into metal oxide, break up into metal oxide plus gas. So now is my voice okay? Loud enough? Okay. Metal oxide and gas remember, metal oxide and gas. So you see, when I hit zinc carbonate, I get zinc oxide, the metal oxide. And then the ion at the back will give me the gas. CO3 will be CO2 okay, because you see, Zn, I remove it already, Zn, 1O. So 3, you take out, it remains 2. CO2, you can temper like that. So ZnO and CO2. For all the rest is the same, just the metal oxide is different. All right, metal oxide and gas is the most important thing. And then for nitrate and carbonate, you see, the main difference is from CO3, it has become NO3. That means the gas just now will change from CO2 to NO2. From carbon become nitrogen, N already, so you get a metal oxide and NO2. And here it comes with another gas because still got extra. So O2, just like that. So when they give you a question in exam, this is what you can do. It's like a little shortcut. It's like a cheat, okay? When they give you salt A, decompose into metal oxide X plus gas, one gas only, then you will know that the one gas must be carbon dioxide. If the salt A being heated produce gas 1 plus gas 2, if you see two gases, confirm 100% nitrate. Just like that. Okay, only got 2. 1 gas and 2 gas. So how do they differentiate the gas? CO2 and NO2 is just a letter different, right? So how do they differentiate it? The one with N NO2, nitrogen dioxide, is a brown gas, which means they will always hint you, okay? They will give you a clue and tell you, this gas is brown. When you see the gas is brown, straight away write nitrogen dioxide. If you see brown gas and then you don't know how to answer, I slap you. I really slap you, because this is too easy. Only got one brown gas, okay? Now, let's continue. Finish already, we finish everything already. Continue with the question in the next page. Come, we go to the next page. In this page, I will give you 1 minute to solve this thing. There is a combination of salt P and Q. We change this one. Salt P and Q. And then the question E is gas Y. You read the questions. You read the question. Find the unknown. Find the unknown. This is heating of salt. Come, I give you 1 minute, faster. Salt P and Q. This is what they say. Salt P insoluble, salt Q soluble. Oh, insoluble and soluble mixed together already. Name process 1 that is used to separate salt P and salt Q. If you have a soluble salt and insoluble salt mixed together, it is like sand and seawater mixed together already. How do you separate them? How do you separate them? You've got sand and seawater mixed together. How do you separate them? How? Yes, very good. Hey, Jeremy is here. Very good. Filtration. Okay, filtration. You just filter it. Okay, then done. You get the insoluble salt out, and then the filtrate will be the soluble salt. Gas X, no lah, okay, because you never answered my question just now. Gas X can turn lime water chalky. So that means gas X, even without reading the question, when I see, oh, 1 gas, 2 gas, I can already tell, this 1X, gas X, confirm CO2 lah. And then the 2 gas must be NO2 with the friend O2. NO2 with the friend O2, confirm. So since they told me that X turn lime water cloudy, I double confirm, I triple confirm my answer is correct. CO2. Okay, so the gas is CO2. What is the N ion present? That means they are asking you which negative ion can produce CO2. Must be the mum lah. The mum is what? Carbonate ion. Carbonate ion is CO3, 2 negative. The mummy is CO3, 2 negative. Produce the sun CO2. Residue W, when you see the word residue, means metal oxide. The metal oxide is yellow when hot, white when cold. What is this? Yellow when hot, white when cold. Yellow when hot, white when cold. What is this? Yes, Putra, very good. This is zinc oxide. Zinc oxide. Okay, zinc oxide. Oh, just by that, finish off zinc oxide. Based on B and C, identify the salt P. So if the reaction can produce, ZNO and CO2, the salt must be zinc carbonate. Zinc carbonate, easy. Next, gas Y is brown gas. Ayo, when I see brown gas, I know the answer because I got study. So nitrogen dioxide gas. And then next, gas Z rekindle glowing wooden splinter. The friend oxygen gas. O2. What is the N ion present? Who is the mummy that produce NO2 and O2? The mum must be nitrate ion lah, to be able to produce NO2 and O2. Gas residue V, the metal oxide is brown when hot, yellow when cold. You see, this is the one that always come out in the exam. If you have, like, if you haven't remembered this one, please remember this. This is lead 2 oxide. Don't write lead oxide, lead 2 oxide. No 2, I minus your 2 marks. Identify residue V, okay, done. Based on E and F, identify the salt Q. Got lead, got nitrate, of course, lead 2 nitrate. Done. One question done. Next. Okay, everybody's okay? Next. Question 18, page 20. 20. Am I going too fast or too slow? Page 20. Same, 1 minute. Solve this diagram. No need to do the questions below. Don't do the questions below. Start lagging already. GG. No need to do this one, but find out all the unknown for me. I want to know what is P, what is Q, what is T, what is R and S. Faster. This year has a very high chance it's going to come up question like this. They give you a chart. You have to find the unknown. 1 minute. Solve the chart. No need to do the question below. Don't. 1 minute starts. Okay, let's look at this question. Is Jinhui here? Oh, yes. Okay. Substance P plus zinc chloride, it gets you zinc carbonate. Okay. Substance P and zinc chloride will get zinc carbonate. So what is this actually? They're asking you what is P. What are they asking you actually? They want to know. To make this, to produce this zinc carbonate, what is something that has to be mixed with zinc chloride to form this zinc carbonate? Does this thing familiar? Does it look familiar? What you learned last week, preparation of salt. If you want to make this salt, you have to know what? The reactant. Last week I told you this, right? Reactant is one of the most important part in preparation of salt. Yes, you went very good. Now I want to make this zinc carbonate. Can you all tell me whether this salt is soluble or insoluble? Yes or no? Yes for soluble, no for insoluble. Okay, very good. The rest of you, yes or no, only faster. Oh, Jinhui, thanks for your answer. Faster lah. Last month already, no more chance to talk to me. Hui En. Julius. Yeah. Jonathan Hall. Hey, Jeremy, where you went? Soluble or insoluble? Yes, insoluble. According to what we learned last week, insoluble. Yes, very good. Insoluble, we pair it with the third cross and spa. You see what they want? Zinc chloride is already here. You see, zinc already got zinc. Now they need the other half, which is carbonate. You just pair it with something on the top. It can be sodium, potassium, ammonium. So I pair it with sodium and make it sodium carbonate. So my answer for P is sodium carbonate. You can write the equation out, and then you will see after they exchange their partner, they are going to get this zinc carbonate. What is the name of process Q? What is the reaction that we use to prepare an insoluble salt? We call it as double decomposition reaction. Double decomposition reaction. So the DDR. When zinc carbonate is being heated, you see one gas straight away, CO2. What is the metal oxide or zinc? Zinc oxide. Very easy. Next, solution T gets you zinc sulfate. It's the same type of question as what we explained earlier. So for those who told me they are stuck in P, right, T just now, tell me the answer. Yitwen, very good. I want to know what is T. I want to know what is T. Jeremy, T, what is T? Julius, I kick you. Yeah. Julius, 可以给我答案吗 Julius? Please. Thank you. Putra. Solution T, not solution P. I want the T. Sabel, what is the answer? Hey, can you please give me an answer faster? Come. Interaction. This Putra, Jeremy, why so slow? What is the acid? Yes, correct. To make this zinc sulfate, soluble or insoluble? Soluble. Got spa or no spa? Che also you don't know how to do. Soluble, but no spa. So we have to use the second cross to do it. Last week got 3 cross. Second cross is COOH. H. COOH. So they give you zinc carbonate. Now you need the other half. Sulfuric acid. Finish lor. Easy or not easy? Done. Sulfuric acid. So let's look at the question what they want. Name process Q. Okay, done. This one. Lag already. Process Q, done. Substance P, done. Changes that occur during process Q. We do this one. A3. Oh no. A3. It is the leg. The A3 changes occur. That means observation. What is the observation that you can see? In the process Q, which they mix Na2CO3 solution. Yes, it went very good. And they mix this zinc chloride solution together. And they get this zinc carbonate. So during this process, what can you see? In this double decomposition reaction, what can you see when the product is formed? Come, I got one correct answer now. The rest of you, give me one more correct answer, please. Jinhui, very good. Observation always give me color. Unless there's no color, you can tell white precipitate is formed. Precipitate means the insoluble salt. You will see when you mix them up together, you will start to see a bit cloudy because the white color salt starts forming out. Write the ionic equation. Ionic equation for the insoluble salt is the easiest ionic equation to write. To make this zinc carbonate, ask yourself the ions needed to form this compound. Zn2 plus, CO3, 2 negative, zinc carbonate. Next, when zinc carbonate is heated, what is the observation? So same, when the product are being produced, what color can you see? Color. Come, try observation. Everybody. Answer. Come lah, answer lah. Pity me, please. Give me some answer. Even you are the best today. My Jeremy, Jeremy, Isabel, answer please. Okay, Putra, good. For BM, they don't call it as purple gel lah. Usually they call it as Baki. Jonathan Ho, good try. Okay. This reaction is going to form ZNO and CO2. Because you all never answer my question, so I don't know whether there's anyone has this answer in your mind, wanted to say colorless gas bubble or colorless gas release. Cannot, because the moment when you say colorless gas release, is not a correct observation because you cannot see the colorless gas being produced. Cannot. Unless you say colorless gas turns lime water cloudy, then can. Okay. Otherwise, you can just talk about ZNO, which is a residue in BS Baki, which is yellow when hot, white when cold, is formed or is produced, also can. Next, a chemical test to identify the gas as, this one I skip lah. Lime water turns cloudy only ma. You know how to write, right? Zinc carbonate reacts with solution T to form zinc sulfate solution. Solution T, sulfuric acid, done. Describe on how to produce zinc sulfate solution. Okay, this is also what you learned last week. The procedure. That means a few simple steps to get zinc sulfate solution. In order to get this zinc sulfate solution, what do? You see, you are going to mix these two reactants together, zinc carbonate and sulfuric acid, correct? But what is the correct way and method to do it? Some specific step you have to follow. Some rule to follow, okay? Precaution steps to follow. So that after you mix it, you get a pure salt. No impurities. What is the precaution? What is the specific steps? This is method 2. Method 2, last week, the second cross. Let it go now. Okay, Isabel, very good. Excess what? Which one in excess? You got two reactants now. You got zinc carbonate and sulfuric acid. Which one has to be in excess? Which one has to be an excess? Isabel, very good. The answer, sorry, Jeremy. The answer is zinc carbonate. Okay. So we will add zinc carbonate a bit by bit. I don't know whether it's correct or not. My English, my England very powder. So I don't know whether this is correct or not, because as that's what I remember. Okay. Or little by little. Okay, I don't know where I have seen it before. Okay, bit by bit into a beaker containing sulfuric acid. Jeremy, very good. This one is very good. Never mind. Okay. Okay, a beaker. But am I right? Can I write like this? Containing sulfuric acid until it can no longer dissolve. Until it can no longer dissolve. That means you will add until the zinc carbonate cannot dissolve. And then what do you do? Now got excess zinc carbonate already. Got extra. Cannot dissolve already. What do? Isabel, what do we do next? Got extra zinc carbonate now. In the solution B? Yes, very good. Filter off the excess or unreacted zinc carbonate and the filtrate obtained is zinc sulfate solution. Will be zinc sulfate solution. Whatever lah. So next. How come I write my answer in the test one? Hiya. So no. Sorry. Blind already, cannot see. Describe briefly on how to verify the presence of cation in the copper 2 nitrate solution. So the cation in the copper 2 nitrate solution is the copper 2 solution, is the copper 2 ion, right? In our cation test that we go through before 2 weeks, not 2 weeks, like in the previous lesson in December, cation test, I told you about the ZAPCM table, right? And then when I tell you this ZAPCM table, I told you also what are the reactants being used to test. Here is ZAP, and then still got 3 chemicals here. They are, the first one, never mind Dylan, Lambo 1. The Lambo 1, okay, is NaOH solution, very good. How about the Lambo 2 solution? What is the second solution? that we can use to test the positive ion? Yes, ammonia solution. Ammonia solution, ammonium something, ammonium hydroxide or ammonia solution. These two can be used to test the copper 2 ion. The first one is the easier one to write. If you use NaOH, your observation will be easier, but we are pro student, okay? We don't, Putra, the last one is potassium iodide, but we don't use that one to test the copper 2 ion. But we are pro student. Pro student, we don't use this NaOH. We use ammonia solution. It is harder to write. So when we write our answer out, we get to show off our skill a little bit. Okay. So what do we write? Never mind, I give you the answer. So we add a little ammonia solution until excess into a test tube containing 2 cm cube of what solution is that? Copper 2 nitrate solution. Okay, copper 2 nitrate solution. And then what is the observation? Can anyone tell me the observation? When I add ammonia solution until excess into the copper 2 nitrate solution, what can I see? What can I observe? Even you are very good. You are my favorite student now. Okay. Just kidding. Okay. What I say already? Oh yeah, correct. Your answer is correct. Blue precipitate is formed. Copper must form blue precipitate is formed. And then dissolve in excess ammonia solution to form dark blue solution. Just like that, okay? So the reason why we write the harder one is because exam always ask this one. They always like to ask the more complicated one because they know you cannot do this. That's why they ask you. So, and this is the also reason why I choose to write this one so that I can revise this with you. Okay. Sometimes they will just ask you the observation. They will ask you, oh, if I add this ammonia in excess, what is the observation that you're going to see? You see, you can write the observation out. Okay, it's not really because we want to show off our skill, but they like to ask us this question. And I want to make sure you can answer this question. So this is the answer. Next question. Next question. The next question, we do page 24. 24. Okay, page 24. Let me look at this. Okay, 24. Say 1 minute. 1 minute, solve the chart. Solve the chart. And then they got tell you some information here. W is a brown gas. Solid Z is white. These are the important information. So please solve the diagram. 1 minute. Start now. So when we look at this one, zinc nitrate being heated, it produces zinc oxide, brown gas, nitrogen dioxide lah. Colorless gas must be the friend of NO2, O2. Easy. Zinc oxide, reaction 1, makes zinc chloride. You see, maybe the first question you cannot do just now, but never mind. After we go through, you already know. When they ask you, what is the acid? When they ask you, what is the solution? To mix together to get the salt, you know you have to use the cross. So zinc chloride under method 2, soluble non-spar, cross, okay, COOH, H. So zinc oxide already got. What is the acid? HCl lah. Done. Zinc chloride plus water, okay. Zinc chloride plus lead 2 nitrate, it gets you white solid Z. Zinc and nitrate is here already. That means the white solid must be lead 2 chloride. Easy. So these three, we got answer already. I skip. Equation, I skip. Describe a chemical test. This one I want to write. Describe a chemical test to verify the N ion present in zinc nitrate solution. Remember the one we did? I asked you to write in a blank paper one. We now want to test the nitrate ion. Let me ask you this question. To test nitrate ion, you got how many steps? Yeah, very good. How many steps? How many steps? Hello, type a number only. How many steps? Isabel? Okay, Julius, thank you. Okay, got 3 steps. Can you all write the answer out? I know, Jeremy, I saw already. That's why I said very good. Okay, next time I call your name, Jeremy, very good. Okay, 3 steps. 3 steps. 3 steps. Please write the answer out. Thank you. Write the answer out. That is the one we did that day. Try. Never mind, try. Got 3 steps. I told you before. Okay. Carbonate, level 1, 1 step. Rocky Chamai and the silver. Level 2, 2 steps. And the nitrate, 3 steps. This is the reason why we want to do revision. So from the revision, you know, I haven't studied this one. So you know what to do. 3 steps. Okay. Now, write. You write yours, I write mine. No copy. Finish. Okay, just like that. That's what we did before. Okay, dilute sulfuric acid go in, followed by iron 2 sulfate solution, and then the concentrated sulfuric acid. You get a brown ring. So the 3 steps, first step is always adding dilute acid. Second step is always adding a salt solution. Third step, concentrated acid. Ta-da! That's the answer. Now, describe briefly how salt crystal is obtained from its salt solution. So this question is asking you, you got zinc nitrate solution. You have the zinc nitrate solution. You want to make it into salt crystal, that means a dry solid. What are the steps that you have to carry out? How do we memorize the 5 steps? What 5 steps are? We call the 5 steps as? We call the 5 steps as? It was very good. The 5 steps are? Jeremy, the 5 steps we call it as? How do you memorize it? Yes, hippo can fly really dangerous. Good. So we will just write them out. Yeah, very good. Hey. So number 1, heat the solution, the zinc nitrate solution. We write the formula better. ZnNO3 to solution in an evaporating dish. To obtain a saturated solution. Of course, if you want to add the 1/3 also can. Heat zinc nitrate solution until 1/3 of its original volume to obtain a saturated solution also can. That is the pro version. The pro version. Second step, can is cool. Cool the saturated solution to room temperature. Cool the saturated solution to room temperature for crystallization to occur. Heat saturated, cool crystallization to occur. Next, fly, filter the salt crystal. By the way, Jeremy, do I have to put S here? Salt crystals. Filter the salt crystal. Okay, yeah. Salt crystals. Okay, just like that, man. Filter the salt crystal. Let me think. And rinse it with a little distilled water. Oh, okay. So this is what we do lah. We got the salt crystal already. We filtered it, just like that. Filter. You even write filter with the filter funnel and filter liquid, we can write, but normally we write filter and rinse together. And lastly, dry. We dry the salt crystals by pressing it in between sheets of filter papers. As long as they can find these 5 steps, hippo can fly really dangerous, then they will give you the marks. Okay, let's continue. Okay, one more. Page 31, 3-1. Page 3-1. Oh, okay, page 3-1. So same, solve this diagram. Some of the information is in the question. So they say that W is a black solid. Black residue must be CuO with 1 gas carbon dioxide. So you can immediately tell that compound J is a CuCO3 salt, which they mentioned here also, green compound J. Copper 2 carbonate is in green color. CuO plus nitric acid. If you write the equation, you're going to get copper 2 nitrate plus water. Copper 2 nitrate plus NaOH. When they add NaOH, they are secretly telling you that they are actually testing the N or cat ion. The cat ion, no? Because the one we did just now, we got mentioned, NaOH is to test cat ion. So now, black solid, done lah, copper 2 oxide, we wrote on the top already. T is carbon dioxide, easy. When W dissolved in nitric acid, a blue solution is obtained, suggests the ion present. So the ion that shows blue color is the copper 2 ion. In reaction 3, a blue precipitate Q is formed. So this is a blue precipitate. Name the blue precipitate. How to find the precipitate? Write the equation up. When they say add NaOH, you add NaOH. CuNO32 plus NaOH. Exchange partner, you get CuOH2 plus Na and O3. So the blue precipitate is which one? Of course, the one with copper. So you call this as copper 2 hydroxide. By the way, copper 2 hydroxide is CuOH bracket 2. Without bracket is wrong. Ionic equation are very easy. CuOH2 needs Cu2 plus and OH minus. To balance the equation, can you see? 2 OH. So that means we need 2 OH minus. Referring to reaction 1, 2, 3, name the compound J, done, copper 2 carbonate, CuCO3. Give the expected observation. If reaction 3 is repeated using ammonia solution instead of sodium hydroxide. So you see, they're actually asking you this question. They said, if we add NaOH, we get a blue precipitate. You see, now, we add NaOH, we get blue precipitate. How about this, when we repeat it by using ammonia solution instead of sodium hydroxide, what is the observation they will give you if you use ammonia solution to test the copper 2 solution? Ammonia, test N or cation ion? Cation ion. Can you please give me the answer in short form? Like you give me a short answer. What is the expected observation when we use ammonia solution to test the solution? To test the copper 2 nitrate solution, I think. Yes. Yes, Ian. Hey, the rest of you. Observation. Last question already. Last already. Observation. Ammonia solution to test copper 2 nitrate solution. Jeremy. So well. No one will give me answer? Jeremy, can you please tell me which ion we are testing right now? We use the ammonia solution to test which ion? To test what ion? Copper 2 ion, right? What is the expected observation? You are so weak. I don't want to talk to you all anymore. To test the copper 2 ion and we use ammonia solution, this is the observation lah. This is the observation lah. Just did ma. Okay, that's all lah. Bye bye. Don't see you anymore. Bye bye. Go rest, go sleep. Bye bye.